Hello everyone, myself Teja Trivikram. I am from second year Tribly B section, and today I am going to explain about how does the voltage regulation and load variation will affect the electrical distribution system. So let's go into the first slide of this presentation. Here we see how the voltage regulation and load variation in electricity distribution systems are. This presentation explores the critical interplay between voltage regulation and load variation in electricity distribution systems. Understanding these relationships is essential for maintaining system sufficiency, reliability, and ensuring the longevity of electrical equipment. We will address the inherent challenges and delve into mitigation strategies that promote a stable and sustainable electricity supply. This overview sets the stage for the comprehensive examination of voltage control in the face of changing load demands, emphasizing the system performance and exploring proactive measurements for the electrical management. So in this slide, we see the voltage regulation and load variations in electricity distribution system. So here the relationship is essential to maintain the system with more sufficient and reliability and longevity of the electrical equipment. So in the second slide, fundamentals of voltage regulation. So now we are going to see the fundamentals of voltage regulations. Let's see what are they. Definition and importance. The definition of voltage regulation is voltage regulations refers to maintaining voltage levels within acceptable limits, typically plus or minus 5% of the nominal voltage according to ANSI C8 4.1 at various points in the distribution system. Proper voltage regulation is crucial for ensuring proper operation of customer equipment and minimizing energy losses. So the voltage regulation is very important to maintain the system very efficiently, and also the proper voltage regulation is crucial for ensuring the proper operation for customer equipments or the needs of the customer, and also it minimizes the energy losses. So the second one is voltage drop. Voltage drop primarily caused by the impedance of distribution feeders and the current flowing through them is a major factor influencing voltage deviations. Understanding voltage drop and implementing strategies to minimize it are essential for effective voltage regulation. So the voltage drop is primarily caused by impedance of distribution feeders, and understanding voltage drop and implementing strategies to minimize it are essential for effective voltage regulation. The key components are involved in voltage regulation include voltage regulators, LTC transformers, capacitor banks, and distributed generation integration. These components work together to maintain voltage stability and optimize system performance. Let's see what are the types and characteristics of the load variation. Definition of the load variation is load variation refers to the fluctuation of electrical demand over time. These variations can be predictable, such as daily seasonal patterns, or random, driven by unpredictable events and customer behavior. So the load variations are very quite common in the morning and in the evening. So it causes the fluctuation of electrical demand over the time. And the daily variation. Daily load profiles typically exhibit peak demand during daytime and evening hours, with lower demand occurring at night. This pattern is influenced by factors such as business operation and residential energy consumption. So just now I said about how the load variations are. Here, the daily variations also. The typical exhibit peak demand during daytimes and the less consumption of electricity is at night times. Seasonal variations. Seasonal load variations often reflect changes in weather conditions. Demand is typically higher in summer due to air conditioning uses and in winter due to heating requirements. These seasonal peaks must be according for in system planning. Also the seasonal variation is plays in the plays a crucial role in load variations, such as uh, in for suppose for some in summer we use air conditioners and coolers etc. to, to keep the temperature less, and it causes the more consumption of electricity, and whereas in winter season we use we used to heat the water by using heaters etc. and electrical geysers. So in the winter, due to the uses of heaters and uh, electrical geysers, the load so the electricity consumption is very high. Impact of voltage regulation on distribution system performance. Efficiency. Optimal voltage levels minimize I square R losses in conductors, leading to increased overall, overall system efficiency. Losses increase exponentially with current, making voltage regulation essential for loss reduction. So the efficiency is the one of the impact of voltage regulation on distribution system performance. This is how the efficiency impact on the efficiency impact on the distribution system performance. And the impact of voltage regulation on distribution system performance is reliability. Maintaining voltage within acceptable limits prevents equipment malfunctions and outages. Improving systems reliability. Studies have shown a direct correlation between voltage zags and equipment failure rates in industrial facilities. And the last one is equipment lifespan. Prolonged operation at over or under voltage conditions reduces the lifespan of the transformers, motors, and other critical equipment. Proper voltage regulation extends to the and reliability to the maintenance. So these three are the impact of voltage regulation on distribution system performance. Let's see how load variation affects voltage levels. Increased loads. Higher current draw result in larger voltage drops along the distribution feeder, potentially causing undervoltage conditions for customer located further from the substation. So in the first level, the higher current draw result in larger voltage drops along the distribution feeder. In the second one, decreased load. Reduced current draw can lead to voltage rise, particularly in systems with capacitor banks and distributed generation. This can result in uh, over voltage conditions and equipment damage. The third one is voltage fluctuation. Rapid load changes, such as those caused by load variations, switching operations, and it creates the voltage flickers, which disruptive to sensitive electronic equipment. So this is how the load variation affects the voltage levels. So when the voltage levels are affected means in firstly in increased loads, decreased loads, and finally at voltage fluctuation. In the voltage fluctuation, the load changes rapidly, so the voltage levels may affect more. Challenges in managing voltage regulation and load variation. Dynamic load profiles. The increasing production of electric vehicles and other variable loads introduces completely to voltage regulation. Residential EV charging can increase peak demand significantly on distribution transformers. So the EVs are getting more number of manufacturing. So that's why the load may be vary at higher levels. Distributed generation, intermittent output from solar and wind power adds variability to low voltage levels. High DG penetration with low local load can cause reverse power flow and voltage rise at the substation. Aging infrastructure. Legacy distribution systems may lack the capacity and control capabilities to handle modern loads effectively. Upgrading infrastructure is essential for maintaining reliable voltage regulation. So these three are the challenges in managing voltage regulation and the load variation. Mitigation strategies for effective load regulation. So now we are going to see the strategies for effective voltage regulation. First one is advanced voltage regulators. Automatically adjust transformer taps to maintain desired voltage levels. So in order to uh, in order to mitigate the effective load voltage, we have to adjust transformer taps to maintain desired voltage levels, compensating for load changes and voltage drops along the feeder. This ensures a stable voltage supply to customers. And the second one is capacitor banks. Capacitor banks provide reactive power support to reduce voltage drop and improve power factor. So we have to provide the reactive power support to reduce the voltage drop and to improve the power factor. Capacitor banks can be fixed or switched, allowing for dynamic adjustment to changing load conditions. And the third one is smart grid technologies. Real-time monitoring and control systems, SCADA. It means the advanced metering infrastructure and optimization enable coordinated voltage control optimized system performance. So these three are the major mitigation strategies for effective voltage regulation. So finally, the conclusion is the future of voltage regulation. Protective, Proactive voltage management is critical for ensuring grid stability. So proacting of voltage management is critical for ensuring grid with more stability, efficiency, and reliability in the face of increasing load demands and integration of distributed generation. And also investing in modern voltage regulation solutions is essential for maintaining a reliable and sustainable electricity supply. And also we have to um, invest in modern voltage regulation solutions is essential to maintain a reliable and sustainable and efficient electricity supply. Ongoing research and development are needed to address emerging challenges and to develop innovative solutions for regulation. So we have to do some researches and we have to develop which are needed to address the emerging challenges and to develop innovative solution for voltage regulation. The future of electricity distribution system depends on effective voltage management strategies that adapt the adapt to the changing landscape of energy production and the consumption of the electricity. So thank you, Anandal.